Hello, everybody. I believe we are live. So let me just increase the volume of this. Uh, Okay, now I think it should work fine. The audio was kind of dismantled before, like not to the ideal one. So we were solving. So by the way, this this is actually the part three of segment tree mastery. By the way, it should work. No? Yeah. So in previous class, we have left on the position or on the idea of how to do range updates, how to use the lazy segment tree idea, and how to propagate based on requirement. We understood how why we need at least, or we have kind of got an intuition why 4 into the number of nodes in the original array is required for segment tree. This is where we have left the previous session. We learned about building, we learned about query, we learned about range updates directly. Of course, if you set L and R to be equal in range updates, it becomes a point update. So we did not study point updates specifically. We directly studied how range updates work through lazy propagation. We can do the point update in the same manner, either setting L equal to R, and it will definitely not be any lazy idea because there is only one path that we are following. Today we will try to solve some questions. This will be a problem solving session on this on segment trees. So we will try to use the range updates, point updates idea in order to solve some difficult questions. Okay, so the first question that we have is finding the building where Alice and Bob can meet. So we are given a zero indexed array, heights of positive integers, where heights of I represent the height of the ith building. If an if a person is in building I, they can move to any other building J such that the jth height must be greater than my height. We are also given array of queries AI BI, where in the ith query, Alice is in building AI and Bob is in the building BI. Return the array answer, where answer of I is the index of the leftmost building where Alice and Bob can meet on the ith query. And if Alice and Bob cannot move to any common building, then set answer of I to be -1. So let's take an example, like heights are 6, 4, 8, 5, 2, 7, and 0, 1, 0, 3, 2, 4, 3, 4, and 2, 2. Given, and the answer should be 2, 5, -1, 5, and 3. So this is the scenario that we have. Okay, so let's think. So first, Alice is on index 0 and Bob is on index 1. Okay, so Alice is at point 6, I believe. So this is the Alice and this is the Bob. Now Alice is on 6, Bob is on, like, Alice is starting or standing on a building which has the height 6, and Bob is standing on a building which has of height 4. So 0 and 1 indices respectively, I believe. AI means, I guess. You suppose AI, I believe, should be, yeah. Now we are saying, that if a person is a, Okay. Okay. So we are trying to find. Let's see. So we are trying to find the first index such that that is greater than me, I guess. Wait, so for example, this six can the person standing at six can go to eight. The person standing at four can also go to eight. Kind of like this situation. So if I'm starts, if I am standing at six, I can go to eight. I can four, I can go to eight. Like six can go to anything that is greater than equal to six, greater than six. It can go to seven as well. But four can go to five, eight, right? Seven. Like four can go into eight, five, seven. Six can go to eight, five. No, not five, eight and seven. So, and I want the minimum of those, I guess. Yeah. So index of the leftmost building that Alice and Bob can meet on the ith grid. Uh, Let's say that Alice is on 0 and Bob is on 3. So they are on 8. In that case, 0, 1, 2, 3, I guess. So Alice is on 0 and Bob is on 3. So, so 6 and 5. So they can both meet on the 7 height building, right? So, okay. So the idea is to find, let's say this two indices are given. Either this index, the value at this index is greater than equal to the value at this index. I mean, height at Bob is greater than equal to, I think Alice and Bob are separate or just, yeah, they can be opposite as well. Anyways, let's say it does not really matter. Like if 0, 1 or 1, 0 is given, I just want to know if they can meet or not. Let's say two indices are given for Alice and Bob. And let's say I sort them. So that this is the smaller index and this is the bigger index. If the person at the smaller index or the height at the smaller index is lesser than or equal to, I mean, I should say less than the height at the bigger index, then this person can jump here and that this will be the answer. If that is not the case, or that means that this is greater than or equal to this person, then I have to find somebody which is right of this and bigger than this, right? Bigger or equal to this, right? So let me discuss the cases. So let's say this is the index I, index first, and let's say index second. Okay. Now there can be two conditions. Like let's say this is H1 or H second and H first. If this HS is greater than HF, that means this first can jump. Then HF is the answer. So HS is the answer. Right? I want the leftmost. I don't think there is any provision for me to, yeah. I can only jump towards the right. Otherwise, if hs is greater than equal to hf, so less than equal to, so it is less or equal to hf. That means I have to find something in this range which is greater than equal to h, right? Yeah, because if this is greater than equal to hf, I know that hf is greater than or equal to. So that means, I mean, I should find something greater than hf in that case. Because if if it is equal to hf, hf cannot jump there. So to find somebody which is greater than equal to hf in the range hs to n, and I want the minimum index. Okay, so we can search, but it is not sorted. So we cannot apply a binary search here. But we want to find some value. What we can do in order to find some value, we can have a maximum segment tree and a minimum segment tree. And I can say that if this is like, if at the node I know that what is the maximum value, what's the minimum value, and the responsibility region. If at any point I am outside the max, greater than maximum or less than minimum, we come back, right? So we will need both segmentations in this case, like maximum and minimum both. If we are greater than maximum or less than minimum, then I will not find the answer below. Otherwise, we can just travel. Of course, we need the leftmost. So we will check if we have found something on the left first. So we'll also have a Boolean variable that will tell me, or of course, I will make the call to the left side first, and I will check if that got me an answer. Then I will return that answer directly, and I will not call for the right subtree. Okay. So let's start solving this. This is the hard problem, of course. Just making the segment trees a little bit harder. So we have the height cell, and we want to have or build a maximum segment tree and a minimum segment tree based on this height cell. So let's use our code. So we have a minimum tree that builds up the tree on the ARR. So we will just copy this. So this builds me the minimum tree, and we will of course change this to AR heights, I guess. So this will build me the minimum segment tree on this height side. This is the option. That's right. Yeah. So build will get me this. Now let's build the maximum segment tree as well. I guess we will need two separate, and we have to rename some functions. Let me just make this full screen. So this is the, I should call this build min maybe. Okay. Let's say build empty, build minimum tree. Okay. So build empty. And let's call this query as query empty. Okay, and on the max tree, you can just say that build max tree. And we can have the query max tree. I should call it MIT min tree, minimum tree, and I should call this build MIT. Okay, so build MIT, query MIT, and we have build MIT, and we will have build image. So we have built the maximum tree and we have built the minimum tree. I guess we have to set this to heights. So now we have built the maximum segment tree and the minimum segment tree on the height cell. Let me just connect my icon. So after this is done, we want to know. So let's go through for VIX through my query. I should say vector int x or say q3 queries, right? So I can just say int Alice equal to q of 0 and int Bob equal to q of 1. For us, it really does not matter which one is on the right side and which one is on the left side. So I can just say that sort q0 all of q, I should say, or beginning of q. Let me push my Alice and Bob accordingly because the answers to these solutions are symmetric. So Alice and Bob have set. Now we can say that either if that height of the second, in this case Bob, is greater than, I believe we have used greater than, right? Greater than heights of Alice, then we return Bob. Or I should build the answer, right? So answer dot pushback Bob. Otherwise, we will try to find. Now, how can we find? Of course, based on the minimum and the maximum. So we have to we have to write a find logic or find function, or I should say that will take in an IDX, LR, LQ, RQ, and I want to know based on if I can find or not. So maybe I should think that this find function, and we will write our find function accordingly. That will use this max tree build. Okay. So first we define that, or let's say I should call this find left. Okay. If this is satisfied, otherwise I will say answer dot pushback find, I think, leftmost. Find leftmost. I mean, I want any value that is greater than, I believe. I think I will need any value that is greater than HF or Alice. Leftmost, I should call. Of course, the index will start with 0, LP will start with 0, and then n minus 1. And I want to find something that is greater than or equal to, right? So I can just put in a value maybe. So what value should I search? If I search HF plus 1, that should work, I guess. Let's try HF plus 1. Or I should say heights of Alice plus 1, right? Yeah, let's try to find that. Okay, so in val, I guess LR, I know. I don't need any LP or RQ, do I? Because I'm not doing anything in range. So I think I will need only one. Four integers are enough. Now I will check that the L and R are the responsibility regions, right? So I can try to maybe check that if my value is less than equal, or I should say greater than equal to, greater than uh, max, max, I guess that was the call of the max tree, right? Or val is less than min tree of IDX, return minus 1. This is the first that will say that not possible. Now, now if they are disjoint, I think we have in the first case, I guess. Okay, so this was the finding part. I mean, this in this case, it was the disjoint part. Now we want to deal with overlap. Oh, no, not overlap. I should say completely within. I should say that if val, or I can just say that so we go left. So we say that if left It's not equal to -1. We want to check if L is equal to R, and in the end we have 4. If we have reached, return L. So I think we can just check that. If this val is greater than equal to, or I should say that heights of L is greater than equal to my val, then return L. And let's say that if right is also not equal to -1, then we can return this right. Otherwise, return -1. I guess this should work. I guess L to y plus 1, L made, and then in place of LQ and RQ, we have possible. This should work, I guess. By the way, let's see if this, how the stream is running well. Okay, let's just check. Okay, so it's looking well. Watching now. Okay. So this should work, I guess. So I guess return answer. Of course, we probably have some bugs that we need to solve to fix, I guess. Okay, I have to declare this n. Carry. Okay, so we find leftmost. Build energy. Which one? 1044. Okay, of course we don't need this building part again. So I think we do need this. Let's check. Uh, First we have this build MIT, right? Yeah, build MIT is working. Build MAXT. Okay. Okay, value is greater than or value is less than minimum, then not possible. Hmm. Okay, wait a minute. Find leftmost, not from 0 to n minus 1. I have to find Bob plus 1, it's 1 to n minus 1. Otherwise, in some cases, 7 is an answer. 1, 2, 3, 4, 5, 6, 7. Let's think this through a little bit. What if, right? Think. We really don't want to find. We want the minimum value, which is greater than equal to my heights of Bob. So maybe not find the value. Maybe try to find. So heights of Bob is greater than heights of Alice. Let me think. It's the heights Alice and Bob are ready. So by the way, I have to continue to. Yeah, well, it is correct in a lot of cases. Bob means no, I have to go from Bob plus one only. Otherwise, it's an issue. I should take the maximum of this plus one. Then plus one, right? Uh, okay. Let me think about this one. One, two, fourth query, right? 3, 0. This gets swapped. It becomes 0, 3. Let's think. Let's think. So, 0, 3, right? And the array is 6, 4, 8, 5, 2, 7, 0. But this cannot jump here. So the answer must be here only. The answer should be 5. And I have answered. Okay, this is 0, 3, right? Okay, this is the second height service. So it has to set 5, 3, 8, 2, 6, 1, 4, 6. We have 5 and a 2. This can jump here, this can jump here, right? So the answer should be 4, I guess. Yeah, but they can jump here as well because the value here is same. Okay, the value is same. So I want to find the leftmost one. Bob plus. So yeah, it's working. But I want to find the leftmost. Maybe the leftmost going logic is wrong. Tell me the val. Val is greater than equal to. No, 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 no. Heights of L. I should say greater than, and I should not say plus one here. Any value greater than this, I find I answer that. Oh, come on. Only the equal to part problem. I guess. Let's see if this gets accepted. There's some wrong answer. Maybe some H cases. So here we expect we gave -1. So what's the query? 0, 1. Let's say 3, 1, 2, 4, 5. So 0, 1 is given. Uh, this can jump here. This can also jump here. So 3 should be a possible answer. So I give the value heights of Alice and max of heights of Alice, max of heights of Bob. So I give 3, right? And it's trying to search for 3. If any heights of L, let me just check. I believe this will not be an error reading, or will it? So this should not return marks, no? Should I? Otherwise, I will check for. Oh, why is this being -1? The answer is clear, I guess. Let's try to output this. We have done mistake in second period. Bob, Alice. So Bob is 1, Alice is 0, value is 1, value is 3. Value at Bob is 1. Value at Paulo is 3. Correct. Maybe there's an issue with this max you find leftmost. I don't see any problem, I guess. just think that LR, ah, this will not be valid because LQ in RQ. Yeah, this is a problem because LR, the LR are responsibility regions 0, n minus 1, pop plus 1 to n minus 1. Yeah, okay. The leftmost is not working well. Okay, so the idea is, yeah, then how will it, yeah, the responsibility regions are just undefined in this case. So what can I do here? Like if L and R are known and LQ and RQ are known. So I can just say that other than, okay, in this case, I can just say that if I don't lie in my region, so R is less than LQ or L is greater than RQ, return minus 1. Standard condition. Next, I can say that that's one way of getting minus 1. Or if maximum of this IDX, or I should say max 3 of IDX is if it is greater than or max 3 greater than no max 3 is less than 12, then I am not getting any answer here. Or min 3 less than 12, max 3 less than or min 3 greater than 12. No, no, no. In that case, like you can answer because any value greater than val I'm acceptable, right? And we say if L is equal to R, then we can return this L. I can just check. And otherwise, I can just define mid, go to left into I plus 1, L R, sorry, L to mid, and then L to mid. I mean, this is the new responsibility region. LQ and RQ, I don't think don't change. Don't does not change. and then again LQ. Probably some more 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's see. Yeah, we cannot really play with the responsible regions. Right equal to how many have I sent? 1, 2, 3, 4, 5. What about left? How many have I sent left? 1, 2, 3, 4, 5, 6. The mid plus one are okay. This is working. So we have changed actually nothing much. We just changed that with the bounds only we have changed. Okay. Wrong answer again. Okay, TLE. Why TLE? Okay, I think we have printed a lot of stuff. If I don't print, then probably because segmentally it should be accepted. Yeah. So actually, uh, only issue was in this case that we were just not playing with the responsibility regions well. I think we can make this code even simpler because if I'm returning from this max tree, it does not really, I will never get into this case. So this is an impossible case then. If max tree is less than val, then I will not get anything. Or if min tree is, or if val is less than min tree, if we want values greater than val, right? Can we prune this further in this region? How long is this stream running by the way? You connect. Oh, just 1 hour. I hope the idea is clear that we are just finding based on some appropriate conditions. The same idea of this joint. Since we are trying to find the any value that is greater than me, I think it should be equal to. Right? Then also we return -1. Actually, we don't require the minimum condition because we are happy with any value as long as it is greater than well. So we don't need to, we cannot prune on that end. Yeah. Okay, this was a very good question. Let's try to solve another question. It's called fruits into baskets. I don't think I've ever solved this question before. Okay, I've solved this before. So, okay, by the way, have I ever solved this Alice question before? Solutions, not solutions, so submissions. Uh, Submissions. Come on. Okay, so submissions. Yeah, I've never submitted this before. 22 minutes ago, I guess. Okay, fruits into baskets. Is this a segmented question? I hope. You're visiting a farm and that was a single row with fruits arranged. Okay, okay. Type of fruit I produce is going to collect as much fruit as possible. The owner has some strict rules. You have two baskets, and each basket can only hold a single type of fruit. Starting with any tree of your choice, you must pick exactly one fruit from every tree, including the first tree. Okay, so can I say that this is basically I will calculate the frequencies of all, and I will take down the maximum two frequencies. I don't think this has anything to do with segmentary. Let's check what if I have submitted the same solution or not. So a map, I just counted. Okay, yeah, normal counting. Okay, I have to be contiguous as well, I guess. Okay, let me see. So let me solve this. I don't think this has anything to do with segmentary, so we'll just forget this. So fruits into baskets. Two, I guess. Okay, you're given two arrays, fruits and baskets. Single quantity. Okay, with these constants, I don't think I require this. Fruit 0 equal to 4 is placed in basket 1. Okay, oops. Okay, this can be solved in segment. Because for every type of fruit, I want such basket whose capacity is greater than or equal to mine. Basically, the leftmost basket whose capacity is greater than or equal to mine, right? If, for example, this 3, 4 will be placed in 5, this 2 will be placed in 3, and the 5 will be placed in 5, but I think only, yeah, so it remains unplaced. The fruit 0, which is 3, can be placed 6, 6 can be placed in 7, and 1 can be placed in 4. If 4 is placed in 5, like we have to make a minimum segment tree of baskets, or I think, yeah, a maximum segment tree of baskets is sufficient, like in the previous question, Alice and Bob. I think we have only used the uh, maximum segment tree only. While finding the leftmost, minimum was not required for us. So we will make a maximum segment tree of baskets. By using the maximum segment tree for every fruit type, I will set find the leftmost person in the basket, and then I will solve that, or I will assign that to that fruit's value, and we will go on doing it. Okay, so from left to right only we are putting. It's not like some dynamic programming is involved that maybe skip this fruit or maybe keep this fruit. Not that. So we will make a maximum segment tree. So let's go to a maximum segment tree. I think I can copy from here. This will be easier. Right? Minimum. This is maximum. This this will build the maximum segment tree is built. I believe in place of baskets I will have So maximum segment input. Now I will use the find leftmost. Same idea of finding leftmost. So we'll find out the leftmost basket whose capacity is like, yeah. So if it is less than, then we reject. Otherwise, we can accept it, right? If the maximum is less than, then we return -1. Yeah. Yeah. So this we have found. Now the left finding the leftmost in a greater or equal. So we can just run through this fruits basket now. I think we should have a place map as well. Or I should say int x to fruits. So for every fruit, we will find out the leftmost index. So let's call this find leftmost index 0, 0, and the -1. And is the basket of same length? Yeah, same length. So 0, 0, and -1. And I will try to search everywhere. So 0 and -1 again. We will try to find out its value. Or in our case, it's x. Any value that is greater than equal to x is acceptable. IDX this. And I can just say that the map of or place of IDX equal to x. If it is not placed already, if empty dot find IDX equal to empty dot end, then only I will just do the placing. Otherwise, unplaced plus plus equal to 0. Plus unplaced plus plus. And we can just in the end it return unplaced. We have to define this n equal to x. I think it should be placed 647. LR, LQRT, val. Okay, I cannot just find anything. I find greater than, no? No, I can find anywhere. Why am I getting zero here? Okay, I have to find somebody who is unplaced, right? But I will place and then I will mark that. So what I will do, I will place to IDX or place to dot find IDX. Let me check if L equal to R. Let me check if it has been already used up or not. Yeah, that's the best approach, I guess. So if we are at the end, so we will check it has, if it has been already used up or not. Otherwise, we will say, okay, find somewhere else. If IDX equal to minus 1, so I could not find anything, then only I'm place plus plus. Let's see print uh, position. Let's see what position we are getting. 1, 0, 1. Right? How can we get 1 again? Okay, okay. Okay. Return L. Before returning L, I have to say place of val equal to L. Now I can return it to besmirch it. Okay, let's try to submit. Wrong answer, H518. Again, so 1, 1. IDX. Should I say IDX? Okay. So for every IDX, I will just set it to be equal to L or the position that I have found. What the meaning of this position place of items? Like for that position, I've assigned a value. That is the L. L, or should I just set it to anything? I can set it to 1 as well. It really does not matter because it's just it mentions that it is occupied. Yeah. Now let's try to solve fruits into baskets. 3 to baskets. 3. Is it the same question with higher constraints? Yeah. I think this exact code will work. Let's try to run. Let's try to submit. Because we use segment tree to deal with higher constraints. Otherwise, if n is up to 300, which was in the previous case, probably because of output, I guess, yeah. Because if the constraints are low, we can do n square. For every thing, I can just manually check. Really again? Okay, let's think why we are not doing. This is an n log n approach, I guess. Do I need map? I think I can just say vector of size n. I'm going to say place equal to 0 and set it to 1 and return L. If L is equal to R, why you got 4N? It should not in ideal cases. Like this is just changing the map to a vector, nothing special. So that we don't have to find every time we are in the loop. So another login we are just not spending. Okay, but this is used, right? Okay, it's just case 4. I guess we will get. Okay, it says it's accepted. 49. God, I was spending wrong time anyway. Let's see if you're spending any bad time anyway. First of all, I don't understand why this should be 4 on. L R is less than LQ or L is less than RQ. No answer. Maximum is less than val. Then also no answer. Zero and minus one. Okay. I don't know. It's passing in this case, but I think the time is 1.4 second. What is the time limit in this? Like, what's the expected time? 16. I don't see any problem. Hmm, let's think what's going on. Okay. Okay, when I am updating, like when this place variable is done, so I have placed this, okay, but that is not really updating my tree in any way. Like I have to say to the table that this area is not available to me anymore. Otherwise, it will keep on searching the entire tree. And this find leftmost is an order of n operation, kind of. Okay, so how can I update this? If it is placed, should I update my max tree that so I should say that and I should say the max tree of L is equal to int min, killing that position, I guess. No, I cannot really say that directly. I should say that update, say update from 0 L R 0 n minus 1 L, and we should go to update to make an update function. This can be a point update because only one point is affected. So, so one more I need. If L is R, then I will just say that not available. Otherwise, I will just mid if mid, I should say position is less than equal to mid, then I will update this Else I will update this, I guess. And in the end, we will just use the combined logic normally. Let's see. Yeah, I need the position as well. I believe that this the build max. Okay, this is update again. Will this affect the time? I'm still going and marking it. No? Uh, some reason to get accepted that every time I'm not going to that max tree position. So maybe if this left side area is completely broken, then I can return from it because I have set all of them as -1, and this can get fired. This will get fired, no? Yeah, and this will again also pass for food baskets too, I guess. Okay? Even though this max logic is just bogus in this question. Probably the fastest solution is the segmentation, a double for loop. So I don't know how, but okay. Okay. I believe this question is understood. So the idea was, uh, I will reiterate. So why was this giving TL? If we think about it a little bit, basically, if some position is affected, we want to mark that position. And if a bunch of positions are getting used up, we want to not go even on the top of those positions or the heads or the ideas that are kind of in the head. So we want to return back. Like, let me show you. Like, for example, these positions are maybe getting used up. So we want all of these nodes to be unaccessible. We don't want to go underneath. Like every time this update happens and this is executed. So the update also clears up the path, setting it to int min. So thereby destroying this or thereby making this easy to fire. So we have solved three questions. This, this, and this. I hope you learned something today. Next day we will bring more questions based on segment trees. Maybe learn some tips and tricks here and there. How we can think about problems in terms of max, min, updates. saving times through updates that we learn. Have a great day. You can support me. It will be the how to support me will be given in the description. Only if you find value in this channel. No compulsion, of course. Have a great day and good night.